topic on the GED mathematical reasoning test. This lesson is vital to your test day success. So while we're going to go through material that might seem intimidating at first, not to worry. You'll come away from this lesson with the tools to handle algebra on the GED mathematical reasoning test with confidence. Now, with that said, before we go through the algebra exercises and questions, let's take a look at what we're going to teach you to do in this lesson. So here's the learning objectives. So by the end of this lesson, you'll be able to, well, let's just run down this list here. You're going to be able to handle expressions and polynomials, writing them, evaluating them, computing them. In addition, what about linear equations and inequalities? We're going to go through those. Following that, quadratic equations, and then, of course, functions. Yes. So when all is said and done at the end of this lesson, you'll be able to translate words into math, accurately manipulate that information in different forms, and solve for the correct answer. So keep in mind that you can pause this lesson at any time. So just keep that in mind and feel free to move at your own pace. Don't rush through this video. Also, at times, I'm going to ask you to pause the video so you can try some things on your own. Finally, if you need to go through the lesson more than once, do it. That's fine. Taking things one tiny step at a time is the surefire way to achieve your goals. Okay, without further ado, let's begin at the beginning with translating. And the very first thing we're going to do in translating is find out what an algebraic expression is and what variables represent. So translating English into math, here we go. So an algebraic expression, what's going on inside of that? Well, you have numbers, operations, and variables. And this is how you can see relationships. So an algebraic expression is a combination of numbers, operations again, which are addition, subtraction, multiplication, and division, and of course variables. Now, what are the variables? Well, variables are letters, and they represent unknowns. So if you don't know the value of something, you can represent it with a letter. Yeah. Also, the letter that's chosen and is used in the same expression represents the same number. So same letter in the same expression, same number. Different letters go with different numbers. So keep that in mind as well. Now let's look at a couple of examples of algebraic expressions with all of this in mind. Here's the first. Now in this expression, remember, x is going to equal the same thing. So to read this expression, first, the value of x is doubled. Let's point that out here. So 2x, that means the value of x is doubled or multiplied by 2. Then the same value of x is tripled or multiplied by 3. And then the last term here is simply that same value of x by itself. All right, let's look at another expression. Here it is. Now, in this case, we have a combination of different variables. We have a d variable, an a variable, and a b variable. So unlike the previous expression, in this expression, since each variable is different, each variable represents a different number. All right, now let's move into translating words into algebraic expressions with symbols. Here we go, continuing translating English into math. Now, here's a chart that contains a great list of examples for translating. So I'm going to go through this carefully. Just follow along with me. The first row, we have product. And product means multiply. So if it's product of 5 and a number, that's 5 times a number. And remember, if you want to represent something unknown, give it a letter, give it a variable. So 5x is the same as 5 times x. In the next row, it's mentioning decreased by, and decreased by goes to minus. Next, we have the sum in row 3. Now, sum means add, right there, addition. But we're also given square of a number, and that goes to this exponent, 2. So that's how you can piece the third row together. Fourth row, this one be careful about, with less than. When it comes to less than, it does mean subtract. We can see that right here. However, the other thing you need to do with less than, in addition to subtracting, is switch the order of the terms. This is something not to miss. So if you have less than, of course, again, it's subtract, but you have to change the order of the terms. So in this case, 6 minus x over 2, that is wrong. Okay? The only thing that's right is x over 2 minus 6. Now, for x over 2, quotient is what's mentioned. Quotient means divide, or in this case, go to fraction form. All right, fifth row. In this row, 1/2 gives us that fraction, and it means multiply. But we're multiplying that number by half, and then increasing by 15. Increase by is add, decrease by earlier on was subtract. All right, second to last row, 4 times multiplying, but we're multiplying 4 by a difference. And difference means subtract. And it's the difference of -3 and a number. Note, a number, we don't know what it is, we give it a letter. In this chart, it's x. So it's 4 times that entire difference, and that's why here we have parentheses that house the difference. The last row mentions the square root. So we can see that radical here, but it's the square root of an entire sum. And sum again means add. So it's the square root of x plus 3, the whole thing. Yes, now, if you need to pause this video at this point to take a closer look at the chart, do so. If you need to rewind things to go back through it with me, do so. And now, let's see how you can use what you've just learned here, what we just talked about, to translate in question form. So here's our first question of the lesson. Please pause your video at this time to read through the question stem and to take a look at the answer choices. And when you're done with that, restart the video and we'll work through this question together. All right, so let's work through. The question at the end of the question stem asks you to choose the expression in the answer choices that represents the amount of the donation. So expressions here, we know we're looking for that. That again connects to our answer choices. Also, we're given a variable that represents the number of tickets. What's that variable, right? What is that? That's the question to ask. Well, what's given is t. So we know that t should be a part of the correct answer. Okay, and it's in each of the answer choices. Now, let's go from the beginning of the question stem. At the beginning of the stem, they give us the word sum, right here, that top line. And sum means what again? What operation? Well, it means to add. So we know that's a part of it. So we need to add $1,500 to something. And with that in mind, when you look at the answer choices, you'll see that every choice has the $1,500 in it. However, choice D doesn't have a plus in it. So it doesn't match what we're looking for, and we can eliminate that. So let's get rid of D. Goodbye. Now we can focus on what $1,500 should be added to, which means that we should focus on this specific question. How many tickets get that 50-cent bonus? Now, as stated in the question stem, there's a 50-cent bonus for each ticket that's sold after how many tickets sold? Well, here it is. It's after the 2,000 tickets are sold. Now, again, T is the total number of tickets sold. So if T is the total and 2,000 is the number of tickets that represent the part of T that doesn't get the bonus, should we add, subtract, multiply, or divide these two terms to represent the number of tickets that get the 50-cent bonus? So remember, T is the total, 2,000 is what's not getting the bonus. How do we put T and 2,000 together to represent the tickets that do get that 50-cent bonus? Well, that would go to a difference, subtraction. That would result in the remaining number of tickets after the first 2,000 sold. So T minus 2,000 must be a part of the correct answer. And if you take a look at all of the remaining choices, A, B, and C, you can see that only one of them has the combination of T minus 2,000. And this means that C is absolutely correct. Wow. So you can see how going step by step, translating carefully, checking the answer choices as you do so, can lead to the correct answer with efficiency. That's the goal on test day. Oh yeah. So now we're ready to take things a step further, right? And let's do that by simplifying and evaluating expressions. Now, note here, simplifying for this expression means performing all the operations you can in that expression. So in other words, we need to get rid of as many things as possible in the expression by combining and canceling terms when possible. Now, here's what we should think about when doing this. This important rule: you can add and subtract like terms only. So again, add and subtract like terms only. And what are like terms? What does that mean? Let's look at an example to figure that out. So here we go with our linear expression. So what are the like terms here? Which terms contain the same variable? Well, 5x and 4x do. So they're the only like terms because there's only one y and only one z term. Now remember that like terms can be combined via addition or subtraction like so. Now to combine like terms, and what happened here to get to 9x, we add or subtract the term's coefficients. And the coefficients are just the numbers that come before the variables. They're to the left of the variables. In this case, the coefficients are 5 and 4. And 5 plus 4 is 9. So 5x plus 4x is 9x. So again, we add or subtract coefficients and keep the same variable. Now, we can replace the 5x plus 4x with 9x in the original expression, like so. And that's the simplified expression. So while we couldn't cancel any of the three different variables here, we could combine like terms for the 2x terms. Now, in addition to canceling and combining, substituting is something else that you can do to simplify and evaluate expressions. So let's see what substituting looks like in a question. Now for this, please pause your video to read through the question stem, take a look at the answer choices, and when you're done with that, restart the video and we'll work through this question together. All right, now, whenever you see an expression, don't worry about how complicated it is. Instead, evaluate what it's telling you to do and check for opportunities to simplify it. Remember, ask yourself whether you can cancel, combine, or substitute. Now, here's the expression we have to deal with. I'll rectangle this. There it is. So for that expression, what do we have to do? Cancel, combine, or substitute? Well, Since we're given what x and y equal, this is about substituting, right? So we have that. So 3 will replace x in the expression, and -6 will replace y in the expression. And if you do that, you substitute it in like so. Now, to arrive at the right side of the equal sign shown here in blue, we need to follow the order of operations. And by the way, the order of operations is covered in full in the number sense lesson. So you can check that out for that full description. But for a quick overview of it, just keep in mind that the order of operations is represented by PEMDAS, right? Or please excuse my dear Aunt Sally. Yeah. So what that means in order is this. First is parentheses. Second is exponents. Third is multiplication and division. That's left to right for the two of them. And fourth is addition and subtraction. Again, left to right for the two of them. So in our expression here, the exponent and multiplication come before the subtraction. And 36 times 3 is 108. So we go from here to there. And -6 squared is positive 36. Keep in mind that a negative times a negative is a positive. Also, if you have an even exponent, the result can never be negative anyway. So that's how you would arrive at the right side of the equal sign here in blue. Now at this point, what do we have to do next to continue to simplify? Well, next in the order of operations, multiplication comes before subtraction. So we have to multiply 8 and 36. And what's the outcome of that? Well, 8 times 36 is 288. There we go. Now, one thing to keep in mind is that a smaller number minus a larger number will always result in a negative number. So again, a smaller number minus a larger number will result in a negative. So 108 minus 288 is negative what? It's negative 180. And this means that C is correct. Yes. Now, up next, we're going to focus on what an equation is versus what an inequality is. That was promised in the learning objectives. And here we go. So an equation, this goes to an equality between two expressions. Yeah, they're equal. So there's an equal sign with something on both sides of it, like this example. That's an equation. Now, an inequality, this connects two unequal expressions. So for inequalities, while equations represent concrete values, inequalities represent ranges of values. So in this case, when you isolate variables here, though, right, we're going to treat them the same. So what that means is the way we isolate a variable in an equation is similar to the way you'd isolate a variable in an inequality. So despite the difference, concrete values for equations, ranges for inequality, we tend to, again, treat the variables the same. However, there's one exception to that. So let's point that out. Unlike equations for inequality, if you multiply or divide by a negative value, it is that specific. So it has to be multiplication or division with a negative. That's when you must flip the inequality sign. So in other words, you change the direction of the inequality sign when, again, you multiply or divide by a negative. So not with addition, not with subtraction, and not with multiplication or division with positives. Okay, now here are the possible inequality signs that you could see on test day. Greater than. Note how that looks. Of course, there's less than. But there's also greater than or equal to, which looks like that. So we have that little bar below the greater than sign. And there's less than or equal to, which has the bar below the less than sign. Now, overall, keep this in mind. The point in the inequality sign always points to the smaller value. And the opening in the inequality sign always opens to the larger value. So point to the smaller, open to the larger. Now, how do we isolate variables? Let's take a look at an example inequality. Here it is. Now, whenever you need to isolate a variable, and this also goes for equations, use opposite operations to move everything that's not that variable to the other side of the equation or inequality. And we always, again, do the same thing to both sides of the equation or inequality. Now, by the way, opposite operations are multiplication and division or addition and subtraction. So for this inequality, we should start by moving 11 away from negative 2x. Now, since 11 is added, the opposite operation is subtraction. So we need to subtract 11 from both sides of the inequality, like so. And the result is this. Now, the result is negative 2x is less than or equal to negative 18 because 11 minus 11 on the left side of the sign is 0. And that leaves negative 2x on that side. And on the right side of the inequality, negative 7 minus 11 is negative 18. And note, we don't flip the sign. At this point, we didn't multiply or divide by a negative. Now, the next thing we need to do is isolate x by removing its coefficient. And that coefficient is the negative 2. Remember, the coefficient is to the left. It's the number to the left of the variable. Now, the operation that connects coefficients to variables is multiplication. As a result, the opposite operation is division. So to remove negative 2 from x, we must divide both sides of the inequality by negative 2. So like so, and there it is. Now, wait a minute, we're dividing by a negative. So what happens to the sign? Well, remember, multiplying or dividing by negatives, again, flip that sign. There we go. So the simplified outcome is this. Negative 2x divided by negative 2 leaves x. And negative 18 divided by negative 2 is positive 9. A negative times a negative is a positive. Mention that. Same thing for dividing. A negative divided by a negative is also a positive. Okay, now, let's see how this careful work will play out in a question. So here's question 3. Please pause your video to read through the question stem, look at the answer. Hello, I'm expert Chauncey, and welcome to the GED live lesson on, that's a part of it, left of the variables. In this case, and that coefficient, y and x are not the same variable, of course. So we can only divide the x's, and x squared divided by x is x. So here's the outcome. 4x squared all over x results in 4x, simplifying as we talked about. But we're subtracting the same fraction from before with the y in it. We cannot reduce, cancel, simplify 8y cubed over x, different variables. Also, keep this in mind just in case you encounter it. Comes before subtract. That like terms can be combined and solved. So t minus 2000 must be a part of the correct answer. And if you take a look at all of the remaining choices, A, B, and C, you can see that only one of them has the combination of t minus 2000. And this means that C is absolutely correct. Wow. So you can see how going step by step, translating carefully, checking the answer choices as you do so, can lead to the correct answer with efficiency. That's the goal on test day. Oh yeah. So now let's translate the number of steps in the the numerator at the top of the slide You'll have to know what operations to use and when. Four. Common. Here's our expression from the question. But also, so we're going to do this piece by piece. To do that, you can only simplify terms that share a common variable. So here's what that looks like. Let's say we're dividing the numerator from before by the variable x. So again, we're splitting, in this case, around the minus sign in the numerator, same denominator for each, which is x. And then to get to the outcome, choice A and choice B, is the inequality sign in the middle. Since Annie has a budget of $1,325, think about what that means in the real world. Can she go over budget here? Or must she stay within the limits of her budget? Well, since there's nothing in the question stem that tells us that Annie can go over budget, she would have to stay on budget, right? She doesn't have more than $1,325 to spend. And after all, that's the point of having a budget. So which choice, A or B, matches that? Which of those two choices means that Annie won't go over budget? Well, that would have to go with B. Yes, B must be correct because less than or equal to matches staying within the budget. For choice A, since it has greater than or equal to, it represents the possibility that Annie goes over budget, which, as we talked about before, is incorrect. Okay, now I'm going to give you some time to try some questions on your own, one by one. Now, keep everything that we've discussed in mind. And here we go. So for question 4, give yourself some time to answer this question. Pause the video, then go to work, right? Step by step. And when you restart the video, we'll review. All right, let's start with the actual question. And here it is. It's actually about what's the number of steps here. Now, based on the givens, let's translate the number of steps in the Washington Monument. We can represent that number with the letter W, right? Let's say that. Now, we know that W is 27 less than something else. It says it right there. And remember, we talked about this with the translation chart. Less than means subtract and change the order of the terms. Switch the order, like this. So instead of 27 minus, it's minus 27. Now, in the answers, nothing has 27. Thank you for that. Now, next we have to translate this portion. 6 times the number of steps in the Statue of Liberty. Now, times, remember, means multiply. So the first term to the right of the equal sign would have to be 6 times the number of steps at the Statue of Liberty, which we know goes along with the S. So this is 6S. And this matches answer choice A, which is correct. Now, how did that go? When you review this lesson, just be sure to take stock of how you approach this question and the remaining ones and the preceding ones. Focus on what you did well, focus on what needs a bit more practice, and then you'll be on the right road to testing. Now, it's time for you to practice on a different question. So let's continue our mixed practice with question 5. Once more, give yourself some time to answer this question. Pause the video, go to work. And of course, when you restart the video, we will review. All right, let's see what happened. Let's review. Now, to create the correct inequality, we need to translate, right? That's the whole point of what we're talking about so far. So what letter represents the number of t-shirts sold? Tell us this in the question. Be careful. It's S. And if the school earns $7 per shirt in terms of S, how much does the school earn in total? So again, for each shirt, school gets $7. Well, if the total number of shirts is S, $7 each, remember, you multiply here. 7S is the outcome. We saw an example of this before when we multiplied the total number by the amount per. We did it previously, right? Now, let's get to the correct sign in the inequality. We can see in the answer choices, we have inequality forms. So they're telling us what to do. Always check out those answer choices, right? Now, the end of the stem says, at least $2,500. And at least means what? Does that mean greater than, less than, greater than or equal to, or less than or equal to? Well, at least goes with greater than or equal to. Now remember here, the point in the inequality sign always points to the smaller value, and the opening always opens to the larger value. So in this case, we have the point going to 2,500, and we need that equal sign as well, of course. And that will account for all values starting at $2,500 and going up. That's what at least $2,500 means. So which answer choice matches this? Which one has the point going to 2,500 along with the bar below that sign to give us the equals meaning as well? Well, the full inequality looks like this based on our information. And looking at the answers, the only choice that has the point pointing to 2,500 with a bar underneath it is D. Yes. So note that choice D changes the order of 7S and 2,500, but it keeps the point in the opening in the actual inequality sign going to the right terms. Yes, and we talked about that carefully already. So our predicted inequality is exactly the same as choice D, just in a different order. All right, great job with that. Now, let's define what a polynomial is. Let's go back to working together. So polynomial, here we go. So this has multiple algebraic terms. That's what it is. And here's an example of one. Probably seen this kind of thing before, right? Now for polynomials, we're going to have combination of coefficients, variables, exponents, and integers. So keep those four things in mind. So let's define each on its own. So here's our expression again, our polynomial. And the coefficients, remember, they're to the left of the variables. Those numbers there. Now the variables are the letters. We mentioned that before. Exponent x squared, so 2 is that exponent there, or the power that x is raised by. And the integer is a number without a decimal or fractional part, and it's left on its own here. So 8 is the integer. Now, for polynomial, if it has just two terms, that's a binomial. Bi goes to 2. So one binomial looks like this, x plus 7. X is a term, 7 is the second term. Another binomial would be y minus 4. Y is one term, 4 is the second term. Now, let's see what happens when we add and subtract polynomials. Let's start adding in the operations. Now, when you do that, adding and subtracting polynomials, you can combine only like terms. So just as we've seen before, like terms have the same variable and, note this, the same exponent. So for example, here are some like terms. Note that same variable x, same exponent 2. The coefficients can and will be different. That's fine. But unlike terms, note that while each of these terms has a y in it, the exponents are different. So they're not like. Same variable and same exponent will tell us that we have like terms. Okay, Now, to add and subtract with like terms, here's what we need to do. Keep the same variable and exponent. That stays. You add or subtract the coefficients. So like this. Here's a little example. Now, note that adding a negative is the same as multiplying +1 by the negative term. So what that means is this. Adding the negative right here, adding negative 6x squared is the same as multiplying that negative by +1. Right? So all of that's there. And then that's the same as subtracting. Yeah. So adding a negative is the same as subtracting a positive, or just subtracting the term. And now that we have that, remember, you keep the same variable and exponent. So we're going to keep the x squared. We, in this case, subtract the coefficients. And 8 minus 6 is 2. So that's how we get to the result, the outcome of 2x squared. Now, if you need to pause the video and review that, please do so. Okay, now that we've gone through adding and subtracting polynomials, what about dividing them? Let's take a look at that. So you can divide a polynomial that has multiple terms, as we saw before, by a monomial, which has one term. So let's do that. Here's an example. Now keep in mind, when you're dividing the polynomial by a number, the monomial 2, just divide the coefficients since we're dividing by the number. So here's what that would look like. Now, note, we can split, and we should split the numerator around the minus sign by placing the same denominator under each term in that numerator. So note that 2 is below 4x squared and below 8y cubed. So now that we've seen that, also note we'd be able to do the same kind of split if there were a plus in the numerator. However, if there's a plus or minus in the denominator of a fraction, you can't split the denominator. All you can split is the numerator. All right, now we can divide the coefficients as we talked about before. So in doing that, it's 4 divided by 2 and 8 divided by 2. And the outcome is 2 for 4 divided by 2, keeping the x squared, keeping the minus. And then it's 4 for 8 divided by 2, and then we keep the y cubed. Now, we can also divide polynomials by a variable, but when you do that, you can only simplify terms that share a common variable. So here's what that looks like. Let's say we're dividing the numerator from before by the variable x. So again, we're splitting, in this case, around the minus sign in the numerator, same denominator for each, which is x. And then to get to the outcome, for the 4x squared over x, that's where we have the same variable, x here, x there. However, y and x are not the same variable, of course. So we can only divide the x's, and x squared divided by x is x. So here's the outcome. 4x squared all over x results in 4x, simplifying as we talked about, but we're subtracting the same fraction from before with the y in it. We cannot reduce, cancel, simplify 8y cubed over x, different variables. Also, keep this in mind just in case you encounter it. You can't divide anything by 0, okay? Now, dividing polynomials can get a bit more complex than this, so let's take a look at that situation right now. So in this more complex situation, look for factors and variables that each term has in common with the divisor. And the divisor is the denominator. So here's a more complex polynomial with division. Remember, we can split the numerator around the plus sign. We did that before. And each part of the numerator will get the same denominator as a result. Don't forget it. After this, we can divide the coefficients. So we're going to do this piece by piece. So we can divide the numbers that are to the left of the variable terms like so. So 8 and 6, they're both even. They're both divisible by 2. So we can divide 8 by 2 and 6 by 2. And we get 4 over 3. Now 6 divided by itself is 1. And that's the outcome we can see below on the left side of the slide. Okay. Now that we've done that, we can divide the variable terms, starting with the x terms. So in dividing the x terms, here's what we need to look at. To the left of the plus sign, x to the 4th power is divided by x squared. And that results in x squared. And to the right of the plus sign, x squared is divided by itself, which again results in 1. So here's the outcome of that division with x. And now that we've taken care of x, it's time to take care of y. So in dividing those remaining terms, on the left side of the plus sign, y divided by itself is 1. But on the right side of the plus sign, y cubed divided by y is y squared. So here is the result of simplifying this more complex polynomial with division. 4x squared divided by 3 plus y squared. Yes. Now remember, if you need to pause and review this, please do so. You can rewind it. And when you're ready, keep moving forward with me. Okay, now, I think it's time to practice applying operations to polynomials in question form. Let's see how this can pay off on test day. So, again, give yourself some time to answer this question, okay? Pause the video, do your work in the right order with the right steps, and when you're finished, restart the video and we'll review. Okay, now remember, please remember, to simplify an expression, check for opportunities to cancel, combine like terms, and or substitute. And for this given expression at the end of the question, we can combine like terms. So let's see how this plays out. So combining like terms. Now, one like term, remember we're looking for same variable, same exponent. So one like term is a squared b. Now, remember we keep the variables with the exponents. We add or subtract the coefficients only. And 3 plus 3 is 6, so this results in 6a squared b. But that's plus what? Now, what's the other pair of like terms? Well, here they are, the ab terms. So when we add those two terms together, remember, again, add the coefficients, the numbers. So we're adding 4 and 5. What do we get? Well, we get 9ab. So here's the full simplified expression. And that means that answer choice D is correct. All right, all right. Let's keep the ball rolling with the next question. So once again, give yourself some time to answer this. Pause the video, do the steps on your own. When you restart the video, we'll review. Okay, now, to answer this question, here's what you need to ask yourself. What are the different terms? In other words, what are the different variable terms that we wouldn't be able to get rid of in the expression? Well, here they are. We wouldn't be able to get rid of j squareds, right? They don't cancel out if we were to do j squared minus 2j squared. So that goes on the list. We also wouldn't be able to get rid of k cubed. K cubed plus 5k cubed, that doesn't cancel out the k cubed. So that goes on the list. We also wouldn't be able to get rid of j cubed, I should say. So for j cubed, there's nothing to cancel that out. Remember, j squared is not the same as j cubed. So j cubed is also on the list. So there are 3 different variable terms that you wouldn't be able to get rid of via simplification. And this means that the correct answer is B. Okay, Let's continue to practice applying operations to polynomials via the next question. Now, please pause your video to read through the question stem and take a look at the answer choices. When you're done reading, restart the video and we're going to work through this one together. Okay, so don't go through the whole thing. Question stem, answers. When you're ready, restart the video and we'll go to work. All right, welcome back. Now, whenever you have to subtract an expression inside of parentheses, including polynomials inside of parentheses, you must remove the parentheses accurately. And to do this, multiply each term inside of the parentheses by a -1. So this is what we're talking about here for what's going on to the right of that minus. So when you're subtracting here, subtracting something in parentheses, each term gets its opposite charge. That's what that means. So positives become negatives, negatives become positives. And that's the same as multiplying each of those terms by a -1. Now, to simplify, on the left, that first parentheses, that first polynomial inside of parentheses, it just stays the same. We take that away. But remember what's on the right of that minus sign, that second parentheses polynomial. Every term gets its opposite charge when we remove the parentheses. So there's the outcome. You need to pause now to nail that down, do so. Okay, now that we're here at this point, it'll be easier to put all of the like terms together. And when you rearrange the terms, as long as you keep the same charge, that's again positive or negative, to the left of each term, you'll have the same expression. So here's the outcome of rearranging this with like terms in order. So note, it's a positive 5x squared. We have that. Negative 3x squared. There we go here. Negative 2x. That stays here. And so on. So again, charge stays to the left, and then the order won't matter. Now that we've rearranged the order here with like terms, it's going to be much easier to combine the like terms, right? So what do you think the outcome will be after you combine the like terms? Well, here's the outcome, right? So we've got to deal with the x squareds together, the x's together, and then the actual integers. By grouping those with parentheses, 5x squared minus 3x squared is 2x squared. Remember, keep the variable and exponent, subtract the coefficients. Similarly, negative 2x plus 3x is positive x. Keep the x. 3 minus 2 is positive 1. And 1 plus 2 is 3. So this matches answer choice C. 1x is the same as just x. Yeah, wow, okay. Now, okay, we've gone through simplifying polynomials via addition and subtraction. We talked about division. But what about multiplying binomials? Remember, binomial has 2 terms in it. Let's look at that right now. So to multiply 2 binomials, here it is. Remember FOIL. And by the way, using FOIL and reverse FOIL is at the heart of solving quadratic equations, which we're going to see a little later. But for now, keep in mind that FOIL stands for first, outer, inner, last. So we multiply or find the product of the first terms, add that to the product of the outer terms, add that to the product of the inner terms, and then add that to the product of the last terms. So here's an example of how that could play out. So here we have multiplying 2 binomials, 2 things with 2 terms. First, we're multiplying 2x and x, and that gives us 2x squared. Outer, we're multiplying 2x and negative 5, that's negative 10x. Inner, we're multiplying 3 and x, that's 3x. And last, we're multiplying 3 and negative 5, that's a negative 15. Now, after this, we can simplify this polynomial in this way. We have like terms here. We have 2x terms. right there. Negative 10x plus 3x. Well, what's negative 10 plus 3? Remember, we add or subtract the coefficients. That's a negative 7. So here's the simplified expression as a result. 2x squared minus 7x minus 15. All right, now before we look at a question, there's something important to add to this. 3 patterns that show up when it comes to multiplying binomials. And these 3 classic patterns also pertain to quadratic equations, okay? So here's the first of them, and here's the pattern. Now, to make this more concrete, let's go into an example that has a number for b. So here's what's going on. In this first classic pattern, numero uno here, what we're seeing is the binomials are the same. So in the example, it's x plus 3 times itself. So in this case, x is a, it takes that place, 3 is b. So as a result, it's x squared replacing the a squared. Then it's 2 times ab, in this case is x and 3. And then it's b squared, which is 3 squared. So this is just about substituting accurately according to this pattern. Now a similar pattern comes next, and here's the outcome of the first one when you simplify. But this next this next pattern for these classic products of binomials is again when the binomial is the same. However, this is when you're subtracting. So if we choose concrete values for the b's, here we go, it's x minus 3 times itself. Similar kind of prospect here. X is a, again, replaces that. 3 is b, replacing that. And you can see the difference between these first 2 patterns lies right here in the middle of the resulting expression. Instead of plus 2ab, in this case, it's minus 2ab. But you're still adding the b squared. And the simplified result of this is x squared minus 6x plus 9. So again, note the difference between these 2. Now, there is one more classic pattern to look out for, and here it is. So this is number 3. This is when you have the same a and b terms in the binomials. However, one binomial has a plus, the other has a minus. And this results in what's called the difference between 2 perfect squares, a squared minus b squared. So to find a concrete value, let's say that b in this case, again, is 3. So a once more is going to be x. We're substituting x in for a. We're substituting 3 in for b. So this turns into x squared minus 3 squared. And 3 squared is 9. Okay, now, as you might suspect again, probably going to see these when you're dealing with quadratic equations. Don't forget that. And keep that in mind from now to test day. If you need to review these, pause the video, go back, and do so now. All right, let's try a question that requires just this, multiplying binomials right now. So for our next question, question 9, please pause your video to read through the stem and to take a look at the answer choices. And when you're done with that, restart the video, and we're going to work through this together. Okay, so let's get to work here. Let's see what's going on. Now, to answer this question, we have to do what we just reviewed in the previous slide. So let's pull out the product of the 2 binomials in that question. There they are. And don't forget about FOIL. So let's go through. What's the product of the first terms? Do that on your own. That's 3x times x, which is 3x squared. Next, we need to add that to the product of the outer terms. What's that? Well, outer is 3x and 2. 3x times 2 is 6x. Then we need to add that to the product of the inner terms. What's that? Well, inner terms here are 8 and x, Multiplying those, we get 8x. And then we add that to the product of the last terms. What is that? Well, 8 and 2 are the last terms. 8 times 2 is 16. Now, remember that we need to simplify the expression if possible. So, what should the simplified expression look like? Can you combine any like terms, cancel anything out? Those are the questions you'd ask. Well, 6x and 8x, adding them together, we get what? 14x. 6 plus 8 is 14. We keep the variable x. So what's the correct answer? B is on the money. Now, keep in mind that what we've just done lays the foundation, as I mentioned before, for solving quadratic equations. So let's go to that finally. Let's take a look now that we've built the foundation. Now, to solve a quadratic equation, note what's going on here. What it really is telling us here in this form is isolate 0 in the equation. So 0 on one side of the equation, everything else on the other side of the equation. And then look for two numbers that add to b and multiply to c. And by the way, this standard form of a quadratic equation is included on the math formulas and symbols reference sheet. That's going to be provided to you on test day. So don't forget about that resource. Now, with that said, what we need to do once you've isolated 0 in the equation is perform something called reverse FOIL. That's when you go from the form noted here at the top of the slide to multiplying two binomials. And that's what we saw in the previous slides. So to make sense of all of this, let's look at an example in the quadratic equation form. Here it is. And note, 0 has been isolated. Always must do that before you perform reverse FOIL. Now, here's the question. What two numbers add to 2 and multiply to negative 15? Adding to the b, which is 2, the coefficient of the x, multiplying to the c, which is negative 15. That's the number without a variable. Okay, so what two numbers do that? Well, to get to 15, here's what you can think with integers. You can multiply 1 and 15, or you can multiply 3 and 5. That would be it. So the question is, which of those two, if we're getting a negative 15, would also give us a sum of 2? Well, it would have to be this in particular, positive 5 and negative 3. Because if you add 5 and negative 3, you get positive 2. You get that b again. That's the key. Obviously, 1 and 15, neither adding nor subtracting them would get us to a positive 2. So we have 5 and negative 3. We know that that's what we have to use in reverse FOIL. So here's how that comes about in reverse FOIL. What times what is x squared? That's our first term. Well, it's x times x. So x will populate the first terms in each binomial, whereas positive 5 goes in one of the binomials, negative 3 goes in the other. And if you're ever confused about reverse FOIL, you can perform FOIL to double check. If we FOIL x plus 5 times x minus 3, we get back to x squared plus 2x minus 15. So this is correct. Again, this equals 0. Now here's the point of isolating 0 before reverse FOIL. Anything times 0 is 0. We know that. So by doing this, by isolating 0, we can set each term equal to 0 to find the solutions. So what that means is either x plus 5 is 0 for this to be true, and if so, x is negative 5, or x minus 3 is 0, and in that case, x is positive 3. So those are the values of x. That's the solution to the quadratic equation. It's true when x is negative 5, and it's also true when x is positive 3. Now, by the way, quadratic equations will yield two solutions for the variable unless the binomials are the same. So if the binomials are the same, then there is only one solution for the variable. Now, don't forget that. And don't forget that two of the three classic patterns that we saw before, uh, that dealt with what I just talked about here, when you have the same binomial. So that was the classic pattern number one and classic pattern number two. Those two will give us only one solution for the variable. The rest of these quadratic equations will give us two solutions for the variable, including that third classic pattern, that difference between two perfect squares. Okay, now, since we've just connected multiplying binomials to quadratic equations, let's look at something else next. Let's shift gears here and focus on functions. Now, as it says here, a function is a rule. So it's telling us what to do, and it shows how the terms in one sequence of numbers are related to another sequence. So functions describe definitive relationships between two sequences. And one of the keys to functions is this. Each distinct number entered produces a unique output. So each unique input gives us a unique output. Let's look at an example of this. Here's an example chart. So you can pause the video, take a look at this if you'd like, see if you can find a relationship that's going on here. Okay, now, based on this example function, for each additional scarf, the cost per scarf goes down by 25 cents. So that would be the input-output relationship here. One more scarf, 25 cents fewer. Okay, let's break down functions even further with this example. F of x equals 3x plus 2. So in this anatomy of a function, here's how you dissect it. F is the function name, so it can have any letter. It could be g of x, h of x, etc. X, what's inside the parentheses, is the input. It's what we substitute in to the output, which is on the right side of the equal sign. And in this case, that's 3x plus 2. Now, to solve for a particular output of a function based on a particular input of that same function, again, you must substitute. And to substitute accurately, read the operations presented by the function. So just like this, given the input x, f of x equals 3 times x plus 2. Now, let's use this concept to answer this question. What's f of 4? So if we input or substitute 4 for x, what would the output be? In other words, if x equals 4, what does f of x equal? Or what does f of 4 equal? Well, let's see. F of 4 would equal 3 times 4 plus 2. 3 times 4 is 12. 12 plus 2 is 14. So that's it. Again, we must substitute to determine the correct output. You want to do that carefully according to the given operations. Now, let's see how functions can appear in questions on test day. So here we go, question 10. Please pause your video, read through the question stem as you've done before, and check out the answer choices. But we're going to work through this together. So when you're done the reading, restart the video, and we'll dive in all together. Okay, now, since they give us a function, let's start there. That's going to be our rule. Don't forget. Here it is. And since S represents the cost of any additional services, what does S equal for Jan? What's the cost of the additional service that she purchases? Well, the cost of Jan's additional service, and remember, that's purchasing the smoke guard. That's $89. It tells us here. So we have to input or substitute that into the function for S like this. Now, we simply need to solve via the order of operations to find the output. Remember, parentheses first. Inside the parentheses, 89 minus 15, and that is 74. So what's the answer? What's 25 plus 74? 99. So A is correct. Now, with what we've just done in mind, I'm going to give you some time to try a few questions on your own, one by one. And the first of these questions pertains to the same given information that we just, but they're going to tweak it. So give yourself some time to answer question 11. Pause the video, go to work, follow those steps, be careful. And when you're done, restart the video and we'll review. All right. Now, once again, we have the same function. Here it is. And in Ahmed's case, his additional service is the installation of a new damper. We know that costs $255. So remember, that substitutes for what? For the S. And now we can solve for the answer. Check what you've done with me. Again, this will be our output here, and that's via the order of operations. Again, parentheses first. 255 minus 15 is 240, and 25 plus 240 is 265. Correct answer is B. Yeah. Now let's go to an unrelated question. Different given information. Again, I'd like you to try this on your own. So question 12, here we go. Again, give yourself some time to answer this question. Pause the video, right? Go to work as always, be careful. And when you're done, restart the video for review. Okay, so let's work through this. Let's check your work here. Now, for this question, we have to choose the correct function out of the two provided in the chart. So we have to be careful there. We don't want to choose the wrong one. Now, since we're solving for the temperature in Celsius, we have to use that function, the C equals function. So you want to make sure you have that in your notes. You don't want the F function instead. Now, based on the question stem, we need to input or substitute 68 for F. That's what they tell us. So here that goes. And now, based on that, for the output, let's follow the order of operations, right? As always, again, parentheses first. So what's 68 minus 32? That's 36. Then we have 5/9 of 36. Now, 5/9 of 36 is the same as 5 times 36 divided by 9. So if you were to use a calculator for this, for instance, you'd still have to know what operations to use and when. So be careful with that. Even when using the calculator, we've got to know how to input the information accurately. So again, this is 5 times 36 divided by 9 in that order. And the outcome, the result of that is 20. So the correct answer is A. Excellent. Okay. Now, there's one more question left in this lesson, and it pertains to a concept we tackled not too long ago. So here it comes. Let's be careful with this one as well. So question 13 for the last time. Give yourself some time to answer this question. Pause the video. Go to work. Think about what we talked about before and how you can apply it to get to the correct answer here. And when you've finished, restart the video for review. Okay, now, you remember what we talked about regarding dividing polynomials? Well, just remember that when we divide by variables, right, we must divide common variables only. And remember that we should simplify the integers as well. Remember, those are numbers without fractional or decimal parts. So let's see how this should play out. Here's our expression from the question. Now, what is the variable that appears in both the numerator and the denominator in this fraction? It's the x, right? Also, note that 3 is in the denominator with x, and both 18 and 6 in the numerator are divisible by 3. So this means that we can divide each term in the numerator by both 3 and x. So in other words, we can divide both of those terms in the numerator by 3x. And here's how that looks. Remember, we can split around a plus or minus in the numerator of a fraction, but each part, once you split, has the same denominator. So 3x is the denominator for each on the right side of this equal sign. And then we can start the dividing. 18 divided by 3 is what? It's 6. And x squared divided by x is what? It's x. Then, to the right fraction, 6 divided by 3 is what? That's 2. And x divided by itself is 1. And y would have to stay. So here's exactly what we just talked about. The outcome here of simplifying this expression is 6x plus 2y. Based on what we talked about previously in this lesson, you can get right to that correct answer, choose A, and move on with confidence. Absolutely wonderful. Okay, now it's time to wrap up by looking at everything we accomplished in this lesson. We're going to go back to the learning objectives that we saw at the beginning of this lesson to do so. So now that you've completed this lesson, you should be able to, and keep in mind, if you need to review this video, you certainly can. Don't be afraid to do that. But right now, what you can do is write, evaluate, and compute with expressions of polynomials. Yeah, we saw that. We just saw it previously, right? Also, dealing with these linear equations and inequalities. We talked about how they're similar. We also talked about the major difference. So equations are about concretes, inequalities are about ranges. But remember, if you multiply or divide an inequality by a negative, flip the sign. So writing, manipulating, solving those we handled. We also handled quadratic equations. Remember, that's connected to multiplying binomials. So link those two things together. That goes along with handling the expressions of polynomials, right? So all of this starts to link up. Lastly, we handled functions, input, output, according to rules. You can compare, represent, and evaluate them now. And that's it. You've received exactly what you need to take care of algebra on the GED mathematical reasoning test. So continue to take things one step at a time, and you're going to reap the benefits on test day. Also keep in mind, review what we talked about in this lesson, right? I mentioned before reviewing by going through the video again if needed. And if you have questions, GED experts at this email address. Please use it. We want to make sure that you get any of your questions that you have answered. Okay, with that said, thanks so much for watching this video, going through this material with me, and happy studying.